Hello and welcome to Algebra 2 Lesson 59. In this video we're going to learn about rationalizing a binomial denominator. So in the last lesson we reviewed how to rationalize the denominator. And we looked at the simple scenario, something like 6 over the square root of 2. So we should all know at this point if we see this is not considered simplified because the rules tell us that we don't want a radical in the denominator. Now, depending on what you get, you might get a square root in the denominator, cube root, fourth root, fifth root, whatever it is, you need to apply a little trick. So with this guy right here, since it's a square root, I'm just looking to multiply by the square root of 2. And I'm going to do that to the numerator and the denominator. That's what makes it legal, right? Square root of 2 over square root of 2 is 1. Multiply by 1, you leave something unchanged. When we do this, we will be radical free in the denominator. Square root of 2 times square root of 2 is 2. 6 times square root of 2 is just 6 times the square root of 2. And of course, we can simplify this further. 6 divided by 2 is 3. So this would end up giving us 3 times the square root of 2. But the main idea here is just to understand that this right here is considered simplified, and it is preferred to this right here. They are the same value. They are equal to each other. But it's just like when we saw something like 1/2 and 2/4. Mathematically, in decimal form, these are both 0.5. But we prefer 1/2 to 2/4, right? 1/2 is considered simplified, and it's the same thing with this scenario here. Now, in this lesson, we're going to look at some more complex scenarios. The first thing we're going to do before we kind of jump into that, we need a little backstory here. So we're going to kind of backtrack a little bit. We're going to learn a definition, and then we're going to kind of move ourselves forward. And I'm going to show you how to do this when you have two terms in the denominator. So when we have two binomials, such as a plus b and a minus b, if the first terms are identical and the last terms are identical, and only the signs differ, you have conjugates. Okay, so here you have a and you have a. Here you have b and you have b. And then your signs are different. You have a positive and you have a negative. You'll recall that we already worked with these before. We just didn't refer to them as conjugates at the time. When you multiply the two together using FOIL, the outer and the inner cancel each other out. And so you're just left with the first term squared minus the last term squared, right? We call it the difference of two squares. So if I had something like a plus b multiplied by a minus b, you could do this the long way. A times a is a squared. The outer, a times negative b, is minus ab. The inner, b times a would be plus ba, or plus ab, however you want to write that. And then the last, b times negative b, is minus b squared. So again, this becomes the difference of two squares. You see that these two would cancel each other. The outer and the inner terms cancel each other. And you're left with the first term squared, so you got a squared, minus the last term squared. So you've got minus b squared there. So we put equals a squared minus b squared. And we know this from working with special products. So let's look at some quick examples. So without doing FOIL, we already know that if we have x minus y times x plus y, it's what? Again, I've got x here and here. I've got y here and here. I've got different signs. I've got a minus and I've got a plus. So I would just say this is x squared, right? The first guy squared, minus the last guy squared, which is y squared. Okay, the difference of two squares. For this guy, we have z plus 4 times z minus 4. So again, if I multiply this out, I get z squared, the first guy squared, minus 4 squared, the last guy squared. Now, you can write 4 squared, or you can just write 16, because we know 4 squared is 16. All right, so we look at x squared minus 9 times x squared plus 9. Again, this would be x squared squared, right? This is what we have here in the first position of each. So it's x squared squared. All right, just think about if I multiplied x squared times x squared. That would be what? X to the fourth power, or x squared squared. Then minus this guy squared. 9 squared is 81. All right, so let's apply this knowledge, and let's look at an example here. So suppose you see 4 over negative 5 minus 3 times the square root of 3. You can't just do this times square root of 3 over square root of 3 like we've been doing. Okay, that's not going to leave your radical free in the denominator. What you need to do is multiply the numerator and denominator by the conjugate of the denominator. So what is the conjugate going to be? Again, the first terms would be the same. So I have a negative 5 here. So for the conjugate, I'd have a negative 5. The signs will be different. If that's a minus, this would be plus. And then this guy would be the same. 3 times square root of 3. So these two would be conjugates. Okay? So what I'm going to do, I'm going to multiply by negative 5 plus 3 times square root of 3 over negative 5 plus 3 times square root of 3. And I know some of you don't believe this, but it's going to end up leaving you with a radical-free denominator. All right, so let's take a look. And you just think about this, putting parentheses around this. 4 would get multiplied by negative 5, which would give us negative 20. And then plus 4 would get multiplied by 3 times the square root of 3. 4 times 3 is 12, so you'd have 12 times the square root of 3 there. Then down here, you basically think about this as using FOIL. But again, because this is something we know already, the outer and the inner, they're going to cancel. Right? I would do negative 5 times negative 5, that would give us 25. The outer, negative 5 times 3 times the square root of 3 would be negative 15 times the square root of 3. The inner, negative 3 times square root of 3 times negative 5 would be positive 15 times square root of 3. And then negative 3 times square root of 3 times positive 3 times square root of 3 would be negative 9. And then square root of 3 times square root of 3 is 3, so times 3. So this would basically be negative 27. Now, again, the outer and the inner are going to cancel. These are opposites. Those are gone. So you're left with 25 minus 27. And what does that give you? It's going to give you negative 2. In the numerator, we have negative 20 plus 12 times the square root of 3. So I'm radical free in my denominator now. I'm not done simplifying, but I am radical free. Now, what else can we do? Well, one thing is, a lot of people don't like having a negative in the denominator. So you could factor out not only a 2, but a negative 2 from the numerator. So let's go ahead and do that. If we factored out a negative 2, we'd have a negative 2 out in front. And then inside of parentheses, we'd have a positive 10 minus 6 times the square root of 3. And this is over negative 2. So what's going to happen is we're going to cancel this negative 2 with this negative 2. And we're left with our answer here. So this is going to simplify into 10 minus 6 times the square root of 3. Now, nothing else I can do to make that any simpler. All right, let's take a look at another one. Again, once you kind of get used to these, they're very, very easy. Not any more difficult. It is a little bit more work because of the simplification, but again, it's conceptually not any more difficult. So we have 2 over 4 times the square root of 2 minus 2 times the square root of 5. So again, all I want to do is I want to multiply the numerator and denominator by the conjugate of the denominator. So this will be the same, and this will be the same. We just have to change the sign. So we would have 4 times the square root of 2. Instead of minus, we're going to have a plus, and then 2 times square root of 5. Okay? Do the same thing for the denominator. And we're going to multiply. So 2 times 4 times square root of 2 would be what? This would give us 8 times the square root of 2. Then plus, if we have 2 times square root of 5, 2 times 2 is 4, then times square root of 5. And then this is over. Down here, again, let's use our shortcut. Let's not go through and use FOIL. We know it would be the first guy squared. So if I square 4, I get 16. If I square the square root of 2, I get 2. Then minus, it would be this guy squared. If we square 2, we get 4. If we square the square root of 5, we get 5. So what we end up with is what? We have 8 times the square root of 2 plus 4 times the square root of 5 over 16 times 2 is 32 minus 4 times 5 is 20. So we say this is equal to, we'll have 8 times the square root of 2 plus 4 times the square root of 5 over 32 minus 20 is 12. I could simplify a little further because I could factor a 4 out from the numerator, cancel it with a common factor of 4 in the denominator. So if we did that, we'd have 4 times the quantity Inside of parentheses, you'd have 2 times the square root of 2 plus, you'd have the square root of 5 over, you could write 12 as 4 times 3, or you could just keep it as 12. Doesn't really matter. You can cancel this with a factor of 4 here. So this would be 3 now. And so our final answer would be 2 times the square root of 2 plus the square root of 5. And this is over 3. All right, let's take a look at another one. So we have 4 over -1 minus the square root of 3x to the 4th power. Now, if you notice something that you can simplify, like you have x to the 4th power under a square root symbol, go ahead and simplify that first. So let's say this is 4 over, you have -1 minus, let's write this as the square root of 3 times the square root of x to the 4th power. So you should all know at this point that, again, if the index is 2 and the exponent in here is a 4, you just divide. 4 divided by 2 is 2. In other words, the square root of x to the 4th power is x squared, because x squared squared would give you x to the 4th power. So we can rewrite this and say we have 4 over -1 minus, this would end up being, again, x squared. So we'll put x squared out in front times the square root of 3. So again, I have 2 terms for my denominator, and all I want to do is multiply the numerator and denominator by the conjugate of this denominator. So -1 will stay the same, and x squared times the square root of 3 will stay the same. We just need to change the sign. If this is a minus, it will become a plus. So -1 plus x squared times square root of 3. All right, so let's put this inside of parentheses, and let's see what happens. 4 times -1 is -4. Then 4 times x squared times square root of 3 would just be plus 4x squared times square root of 3. Then this is over. For in the denominator here, again, we could skip through using FOIL and just use our shortcut. We know we would just square the first one. So if I squared -1, we would get 1. Then we'd have minus. We would square this guy right here. X squared squared is x to the 4th power. And then the square root of 3 squared is 3, so times 3. So what is this going to be equal to? We'll have -4 plus 4x squared times the square root of 3 over, we would have 1 minus, and you can just write this as 3x to the 4th power. Now, is there anything else I can do to simplify here? Well, I could factor out a 4 or a -4 from the numerator, but nothing I can really cancel that with in the denominator. There's not really anything else we can do to simplify, so we just report our answer as -4 plus 4x squared times the square root of 3 over 1 minus 3x to the 4th power. All right, let's take a look at another one. So suppose we see 6a over, you have the square root of 3a squared minus the square root of 2a squared. Again, if you see stuff you can simplify, go ahead and do so. So we would have 6a over, if I just pulled this out, remember the square root of a squared is just a. So we would have a times the square root of 3 minus, same thing here, square root of a squared is a. So a times the square root of 2. Now, again, all I want to do is multiply the numerator and denominator by the conjugate of this denominator. So let's just rewrite this real quick. We'll have 6a over, we have a times the square root of 3 minus a times the square root of 2. So we're going to multiply this by, again, the conjugate of the denominator. So we're going to have a times the square root of 3 plus, right, instead of minus, a times square root of 2. So what are we going to do? We'll have 6a times square root of 3. So that would give us 6a squared times square root of 3. Then plus 6a times square root of 2 would be 6a squared times square root of 2. And then this is over. Again, for these, we could use our special products formula. So I'll take the first guy and square it. So I'd have a squared times the square root of 3 squared is 3. Then you'll have minus. We take this guy and square it. We'll have a squared multiplied by the square root of 2 squared, which is 2. Now, there is something I can cancel. In every term of the numerator and in every term of the denominator, you have an a squared. So you can go ahead and factor that out. So if we factored out an a squared, we'd be left with 6 times square root of 3 plus 6 times square root of 2 over, down here if we factor out an a squared, we'll be left with 3 minus 2. So what does that give us? This is going to cancel with this. And so what we're going to end up with is 6 times the square root of 3 plus 6 times the square root of 2. Now this is over 3 minus 2, which is 1. Now I can put it's over 1, or I could just leave it like it is because anything over 1 is just itself. So our answer is just 6 times the square root of 3 plus 6 times the square root of 2. All right, again, let's take a look at another one. So we have 2 plus 8 times the square root of x to the 4th power over 3 times the square root of 3x cubed minus 6 times the square root of 5x. So again, if there's something you could simplify, go ahead and do that before you start. So we could simplify this, and that looks like that's it. So we'd have 2 plus 8 times what? The square root of x to the 4th power is x squared. So 8x squared. And if you wanted to, you could reorder that and say you have 8x squared plus 2. Doesn't really matter. Then this is over. For this guy right here, if we have the square root of x cubed, we could say that we had the square root of x squared times the square root of x. Right? We can break that up. The square root of x squared is x. So what we can write this as 3x times, you'll have this guy and you'll have this guy. So the square root of 3 times the square root of x, we'll just write that as the square root of 3x. And then minus 6 times the square root of 5x. Now again, once we've got to this step, all we want to do is multiply the numerator and denominator by the conjugate of this denominator. So we have 3x times square root of 3x minus 6 times the square root of 5x. So we're going to multiply this by, we'll have 3x times the square root of 3x. Instead of this being minus, we'll put a plus, and then 6 times the square root of 5x. This is over. Again, 3x times the square root of 3x plus 6 times the square root of 5x. We're going to use FOIL in our numerator. So 8x squared times 3x times the square root of 3x. You would do 8 times 3, that's 24. You would do x squared times x, that's x cubed, and then times the square root of 3x. For the outer, you would have 8x squared times 6 times the square root of 5x. 8 times 6 is 48, so plus 48. And then you'd have x squared, and then times the square root of 5x. For the inner, we have 2 times 3x times the square root of 3x. So plus 6x times the square root of 3x. And then for the last, we have 2 times 6 times the square root of 5x. That's plus 12 times the square root of 5x. All right, so then this is over. In the denominator, again, I'm going to use my special products formula. 3x times the square root of 3x squared. So 3x squared would be 9x squared. The square root of 3x squared would just be 3x. So times 3x. And if we did this calculation now, we'd have 27x cubed. So let's just go ahead and write that. Then minus. From the second guy squared, 6 squared is 36. And then the square root of 5x squared would just be 5x. So 36 times 5 is 180. So we'll put minus 180 and then times x. Now, is there anything I could do to further simplify here? Well, if we look, not everything has an x. I'm missing that from right here, right, when we talk about in terms of being able to factor out an x and cancel. So that's not going to work. But everything is divisible by 3. So we could pull out a 3 from the numerator and from the denominator. So that would leave me with 8x cubed times the square root of 3x plus 16x squared times the square root of 5x plus 2x times the square root of 3x plus 4 times the square root of 5x. Then this is all over. If I pulled out a 3, I'd have 3 times. You'd have 9x cubed minus 60x. So let's go ahead and cancel this 3 with this 3. And what are we going to be left with? We're going to have 8x cubed times the square root of 3x plus 16x squared times the square root of 5x plus 2x times the square root of 3x plus 4 times the square root of 5x. And this is all over. We'll have 9x cubed minus 60x. All right, for the last problem, we're going to look at one that's a little bit complex. We get a lot of emails on this type of problem, and it's something that when we taught this back in Algebra 1, we saw a lot of questions on this because it's a very popular bonus question for a homework or for even a test. So let's say you saw something like 4 over the square root of 3 plus the square root of 7 minus the square root of 6. You don't have 2 terms in this denominator, you have 3. So how do we rationalize here? Well, we're going to use the same concept, but what we're going to do is we're going to group 2 of the numbers together. So let's say we grouped the first 2 numbers together, and let's just say we called this A. Then we have minus, and then let's just call this one B. So we have A minus B. If I had 2 terms in the denominator, and one was A and one was B, and I had this minus sign here, the conjugate of that would be A plus B. So again, with this being A, this square root of 3 plus the square root of 7, I would just change the sign here. This is minus, so now it's going to be plus. And then my B is the square root of 6. Then this is over. Again, you do the same thing. So square root of 3 plus square root of 7 plus square root of 6. Okay, so let's do our multiplication. We're going to see where we're at. So 4 times the square root of 3 would be 4 times the square root of 3. Then plus 4 times the square root of 7 is just 4 times the square root of 7. Then plus 4 times the square root of 6 is 4 times the square root of 6. Then this is all over. Now you can go through this the long way, and you could take, let's say, the square root of 3 and multiply by every term here. Then you could take the square root of 7 and multiply by every term here. Then you could take negative square root of 6 and multiply by every term here. And then you can cancel all those things. Or again, you can realize the shortcut. I can take this and multiply it by this. So in other words, I can take this first part, or what we labeled as A, and I could square it. So I could have the square root of 3 plus the square root of 7 squared. Then I could subtract away this second guy, which is the square root of 6 squared. Right? I could treat it again, just like this was A and this was B. So if I had A minus B times A plus B, again, that's what I would do. Right? That's my special products formula. No different here. All right. So let's simplify here. So we have 4 times the square root of 3 plus 4 times the square root of 7 plus 4 times the square root of 6. This is over. We can use a special products formula for this as well. I would have the first guy squared. So the square root of 3 squared is 3 plus 2 times the first guy times the second guy. So 2 times the square root of 3 times the square root of 7 would be 2 times the square root of 21. And then you'd have plus the last guy squared. So the square root of 7 squared is 7. Now 3 plus 7 is 10. So you might as well just put this as 10 plus 2 times the square root of 21. Then minus, lastly, you have the square root of 6 squared. So if I square the square root of 6, I get 6. So 10 minus 6 is 4. So this is 4 plus this guy. Now you might say, hey, that didn't work. We still have a radical in the denominator. Yeah, we do, but what is this? This is a binomial denominator. We already know how to do that. So we took an extra step, and now we're at a point where we can just multiply again by the conjugate. 4 minus 2 times square root of 21 over 4 minus 2 times square root of 21. And again, I know this is a very tedious problem, but it's something that, again, if you get this as a bonus on a test, it's really worthwhile to know how to do something like this. So what we're going to do is we're going to take 4 times the square root of 3 and multiply it by 4. So that's going to give us 16 times the square root of 3. Then we'll take 4 times the square root of 3 and multiply it by a negative 2 times the square root of 21. 4 times 2 is 8. Square root of 3 times square root of 21 is going to be the square root of 63. Then next you'll have plus. You have 4 times square root of 7 times 4. That's 16 times square root of 7. Then next we have 4 times square root of 7 times negative 2 times square root of 21. That'll be negative 8 times the square root of 147. Then we have plus 4 times square root of 6 times 4. That would be 16 times square root of 6. And lastly, and let me kind of rewrite this so I can fit it all on the screen. So we have 16 times square root of 3 minus 8 times square root of 63 plus 16 times square root of 7 minus 8 times square root of 147 plus 16 times square root of 6. Let me just erase this. And we'll kind of drag this up. Okay, so the last one was 4 times square root of 6 times negative 2 times square root of 21. So that's negative 8 times the square root of 126. Okay, now this is all over. Again, if I'm multiplying here and I have conjugates, I just need to do the first guy squared, so 4 squared is 16, minus the last guy squared. 2 squared is 4. Square root of 21 squared is 21. So what's 4 times 21? That's going to give us 84. So 16 minus 84. And if we do 16 minus 84, we'll get negative 68. So let's write negative 68 here. You notice that the numbers that are multiplying these radicals are all even numbers. You've got 16, you've got a negative 8, 16, a negative 8, 16, and a negative 8. Now this is negative 68. So if we think about between numerator and denominator, there would be a common factor of 4, or you could also do negative 4. Just depends on what you want to do. I'd prefer to cancel a common factor of negative 4. I just like to report my denominator as positive. So in the numerator, instead of 16, I'll have negative 4. So we'll put negative 4 on front times negative 4 times square root of 3. And then this would become positive 2. So plus 2 times square root of 63. This would become negative 4. So minus 4 times the square root of 7. This would become positive 2. So plus 2 times the square root of 147. This would become negative 4. So minus 4 times the square root of 6. And lastly, this would become positive 2. So plus 2 times the square root of 126. Then this is all over negative 68. Now, if we cancel a common factor of negative 4 between numerator and denominator, this will end up being positive 17 down here. Now, we're still not done because there's more things that we can do. So I have negative 4 times the square root of 3 plus 2 times. The square root of 63 is the square root of 9 times the square root of 7. We know the square root of 9 is 3. So you'd have 2 times 3, which is 6, times the square root of 7. Then you have minus 4 times the square root of 7. Then you have plus 2 times the square root of 147. Now, let's stop for a second. 147, we don't work with that very often. But this is 49 times 3. Now, we know that 49 is what? It's 7 times 7. So I could say we have the square root of 49, which is 7, times the square root of 3. So 7 times 2 would be 14. So this would be 14 times the square root of 3. And then you have minus 4 times the square root of 6. And then lastly, plus 2 times the square root of 126. 126 is 2 times 7 times 3 times 3 or times 9. So 9 is a perfect square. So again, if we pull that out, the square root of 9 is 3. So I could make this 2 times 3 or 6 times the square root of 14. Okay, now this is all over 17. All right, so what do we have here that we can combine? You've got a negative 4 times the square root of 3 and 14 times the square root of 3. So those are like radicals. So we can say that's 10 times the square root of 3. Then we've got 6 times the square root of 7 minus 4 times the square root of 7. Those are like radicals. We say that's plus 2 times the square root of 7. Then we have minus 4 times the square root of 6. Nothing we can do with that. And then lastly, plus 6 times the square root of 14. Nothing we can do with that. And then this is all over, again, 17. So that's going to be your final simplified answer. Nothing else we can do here. And again, I know it was a long problem. I know it was very tedious. But it's something you should get used to doing in case you get that as a bonus question on a test. Something you can do and make up for any problems you encountered that you couldn't solve. So we've got 10 times the square root of 3 plus 2 times the square root of 7 minus 4 times the square root of 6 plus 6 times the square root of 14 all over 17.